Linear equations show up everywhere on SAT tests, so it's crucial to master them. Let's start. In our first example, we have an equation, but the x has a rational coefficient. What should I do in this case? Well, there's an easy way. I can either solve it like this, like put this 4 to the other side of the equation as minus 4 and it becomes 2, and then pass this divided by 3 as multiplied by 3 to the other side of the equation, and I can get 6. What else? Well, I can expand these denominators. You see, they have these denominators and I can equalize them. Like if I expand them with 3, then I will get something like this. And then by multiplying both sides of the equation, I can get rid of these 3's, and what I will get is x equals 6, right? Depending on this equation. And there is there is one more way I can do this. Okay, now I can send the additive inverse of this number in order to reach x, like add minus 4 to the both sides of the equation, and then I get x divided by 3 equals 2, and then I multiply both sides of the equation by 3, and then these cancel out each other, and then I can find x equals 6. Well, all these are options, all help in ways that all are helpful, so you should know all of them. Okay, let's move on to another example. Now, in this case, I have a parenthesis here, and this parenthesis changes everything, because in order to simplify the equation, I need to do it first. Now, what I need here is the distributive property of multiplication, and I distribute this 3 as a multiplication over this term x and minus 2. Let's do it. 3 times x makes 3x, and 3 times minus 2 makes minus 6, plus 4 equals 2x plus 1. Okay, let's continue solving it. Now, these are like terms, so I add them. This makes minus 2. In this case, it's very important to put the unknown in one side of the equation and the number to the other side of the equation. Well, the sides don't matter, but I usually put x on the left side. So let's take this 2x and send it to the other side of the equation as minus 2x, like this. And let's put this minus 2 to the other side of the equation as plus 2. So it's now x equals 3, you see? Okay, now let's do this one. Now I will distribute this minus 2. But be careful. Actually, you can view this one as x plus minus 3, and this minus 2 is actually multiplied by this minus 3. So that's how I'm going to do it. Minus 2 times x makes minus 2x, and minus 2 times minus 3 makes plus 6 equals 4x plus 6. Now, as I told you before, I will keep the unknowns on the left side and the numbers on the right side. So this 4x goes to the other side of the equation as minus 4x, and this goes to the other side as minus 6. Okay, minus 2x minus 4x equals 6 minus 6 minus 6x equals 0, and then you get x equals 0. Okay. Let's keep going. Special cases, no solution, or infinite solutions. Okay, this is very important because it may get confusing when you face with it. In this case, and now this is the first example and this is the second example. In this case, you see, when you put this 2x to the other side of the equation as minus 2x, it becomes 2x minus 2x equals, now I put this plus 5 to the other side of the equation as minus 5, so it will become minus 3 minus 5, and now 0 equals minus 8. Such situation cannot exist, so we say there are no solutions to this equation. And let's check out this one. This is 3x plus 6, right? When I distribute this 3 equals 3x plus 6. So I put this to the other side and this one to the other side of the equation. 3x minus 3x equals 6 minus 6, and 0 equals 0. Well, this is a true statement. This statement is true. This means regardless of x, whatever I put in x, this equation will be true. This means there are infinite solutions. This is the case where you get infinite solutions. This is also called an identity. Okay. Let's move to the next one now. Systems of equations. Now we have two variables. You must be very careful with them, and you may choose different methods, and you should know when to pick which method. Okay, let's start with this one. In this case, y is given, and there's another equation given here. You see, if y equals 2x plus 1, then you can use this 2x plus 1. You can substitute it here. This is called the method of substitution. If these are equal, then I can write 2x plus 1 instead of y. That's very important. It's like substituting a player. Okay, plus 2x plus 1. You see, I write 2x plus 1 instead of y equals 13. Now I will just solve this equation. 5x plus 1 equals 13. This goes to the other side. 5x equals 12 and x equals, now this 5 goes to the other side as divided by, so 12 divided by 5. Or I can tell you this, I divide both sides by 5, so it becomes 12 over 5. Now let's check out this one. This one's a little bit different. Of course, in this case, you can say x equals something. You can find that and then substitute it, but it will be hard. In this case, there is something that's begging to be done. It is eliminating these. You see, on one equation, it's plus 3y, and on the other, it's minus 3y. So when you add them up, they should just disappear as they are the additive inverse of each other. So what I do is, I add them. Okay, I will add this part and I will add this part, and this part will equal this part. Now, 2x plus 4x makes 6x, and 3y plus minus 3y makes 0. So I don't have to write it, equals 18. And in this case, dividing both sides by 6, I get x equals 3. You see? Now the substitution method looks cool, but it won't be as easy as this one as always. I should try different linear equations like 2x plus 3y, let's say, equals 6, and 3x plus 2y equals, I don't know, let's just make up some number. Let's call it 12. Okay. There is no substitution in this system of linear equations, or there is no elimination right now, but I will create one. Remember, when one is positive and one is negative, we add them up and then they become 0. I eliminate them. So I want to put this system of linear equations in such a way that they will eliminate each other. Meaning, if I multiply this part of the equation, suppose I will eliminate 3y. So I multiply it by 2, which is the coefficient of this one, and I multiply this one by 3, which is the coefficient of this one, but with minus 3, so that now they can eliminate each other. Keep watching. Now it becomes 4x plus 6y equals 12, right? I multiply everything by 2 here, and I will multiply everything by minus 3 here. Minus 9x minus 6y equals minus 36. You see this? Now I can eliminate this part of the equation. I will add them up. These will eliminate each other. Now minus 5x equals minus 24. This means x equals 24 over 5, as these minuses will eliminate each other. I can write this instead of x and then find y, like 2 times 24 over 5 plus 3y equals 6. And then I can do the rest just like I did the ones in the beginning of the video. Or when I have these systems, suppose I found x, I have an x value. If I use this x value in any of these equations, I can easily find the other value. Let's try it with this one now. Which one seems easier? Okay, let's do this one. Y equals 2 times 12 over 5 plus 1. Well, this amounts to 24 over 5 plus 5 over 5. This is 29 over 5. You see, this is just one unknown equation and you can solve it easily as we did with the ones in the beginning of the video. That's about it. I hope you enjoyed this video and we'll keep our SAT tour. See you in the next one. Bye bye.